Some things are even better when cooled. For the first time, Phoenix Contact is offering a means to dissipate heat from its ICS electronics housings, thus expanding the variety of applications for this housing series. Today, Carolyn and Frank are here to demonstrate to you the strengths and benefits of thermal management. Frank, you are addressing the topic of thermal simulation as a product manager. What was it that made you think about this topic in the first place?
We recognize that our customers have to address certain extra topics. Those include miniaturization, a higher packing density on the PCB, and also the topic of higher performance. This leads to completely new challenges for the customers. And, concerning the topic of thermal management in particular, we're happy that we're able to support them even better than we already do.
And how exactly do you plan to support the customers?
There's two offerings we want to launch in time for Hannover Messe 2020, the first of which addresses the topic of Heatsinks, which Carolyn is going to tell us more about in a minute. And the second is about thermal simulation, by means of which we want to provide support to our customers already during the early phase of designing. As I said, starting in time for Hannover Messe 2020 for the ICS housing series. Our other housing families will follow later on.
Can you explain to us the process in a little more detail?
Sure. Regarding thermal simulation, all starts with our housing configurator, which our customers can use to complete their individual ICS housing by selecting a lower part and upper part. Combining those with the connection technology and the bus system, and in the end, the customers will be taken to a solution page from where they can launch an editor for thermal simulation. In a first step, the customers then need to specify their ambient conditions, that is, temperature and mounting position, before placing their hotspot on the PCB accordingly, giving it its particular power loss. Based on this simplified model created by the customers, we do an automatic thermal simulation and send the customers their individual result. To support them at an early stage in the development process with a first idea about the thermal situation on the printed circuit board. This should help them to work out the right measures to implement.
Carolyn, you are a Heatsinks product manager. Will you explain to us how the use of a heatsink can be such a measure and how heatsinks work?
Every electronic component generates heat, and as power increases, more heat is generated. It is crucial that we send this heat out of the housing because if we don't, the components will be damaged by overheating, or the heat may even cause the device to fail. When measures such as ventilation slots in the housing or changing the way the components are laid out on the printed circuit board are no longer effective, heatsinks come into play. Such heatsinks are made from a thermally conductive material, for example, aluminum, and they are connected to the components, enlarging the surface through which the components can dissipate heat. Due to thermal radiation and convection, the dissipated heat is transferred from within the housing to the outside.
What is so special about this heatsink?
Well, these heatsinks have been designed specifically for our ICS housing series, and they complement our modular housing portfolio. They are special because they install easily by simply pushing them into the housing. Another special feature is that they can be specifically modified to connect to our customers' different components. Thanks to this effective heat dissipation, which the heatsinks achieve, the ICS series electronics housing can now be used in thermally demanding applications.
Great! Thank you very much, Carolyn and Frank, for giving us this overview. Now, if we have made you curious about ICS thermal management, please visit us at phoenixcontact.com.